This video is meant to talk through Lesson 5, pages 0, 1, and 2. So in the simulation in the previous lesson, we saw that a water molecule slowed down and seemed to lose kinetic energy when it collided with the ionic compound potassium chloride. This collision caused the ionic compound potassium chloride to split into a positive potassium cation and a negative chlorine anion. So the question is, where did the kinetic energy go? Okay, so just to kind of make sure that we're all on the same page here, we saw the water molecule slow down, meaning it lost kinetic energy. It is intended that as you're reading through this, you are cued to the fact that if the water molecule lost kinetic energy, that means that we have a loss in temperature, okay? So it's important to remember here, and this is in the lesson 5 notes, that temperature is a quantitative measurement of the average amount of energy within a substance. So when we saw that we had a decrease in temperature, that also means that the molecules literally started moving slower. So just to start thinking about this, we want to start thinking about what types of energy there are and how these different types of energies play a role within our chemical reactions. So we want to look at these 4 balls in this picture. Each is held at a different height. Okay, so I know A and D look like they are held at about the same height. We're asking you to kind of ignore that, okay? So just kind of assume that they're at different heights. Rank the relative energy of each ball at its starting location from highest to lowest. The important thing here is that you're recognizing who has the highest energy and who has the lowest energy, okay? And describe why. The A and D that kind of look like they're the same, as long as those are in the middle, we're good. So then you're asked to think about, so who has the most energy? Where does this energy come from? And then also try to think about what the speed of the balls is as they hit the ground. Now, I know that we have not talked about the physics related to this situation. Really just try your best here, okay? Moving forward to the next page, you're given some more information. And again, we're reminded of the law of conservation of energy that basically just says energy cannot be created or destroyed. It always has to just transfer from one object to another. And so after reading this and after kind of rethinking through this picture, we want you to come up with your own definition for potential energy. Okay, so just try your best here. Try to use context clues from this lesson.